Okay, hi guys, Lois here, and in this video we're gonna talk about some methods to solve the system of linear equations without graph. Okay, let's move on to first warm-up example. I got two equations right here which are linear. The first one is the yellow, this one is the yellow line, and this one is the green line. And as we all know, the solution is this point, which is the intersection of two lines of using graph method. But there's a question that can we solve this without using graph method? And the answer is yes. And in this video, I'm gonna talk about two more methods of algebraic to solve that. And we don't need to use graph. Okay, so the first method here is substitution. And here, the first example, I will demonstrate how to solve it by substitution. So the step one, okay, as you guys can see, here we got two of the y are isolated already on one side, right? So I replace y equal to 2x plus 1 from the first equation to the second equation, right? So therefore I got 2x plus 1 equal to minus x plus 4. And step 2 is solve for x. I already got this one, so it's the same thing with I put the equation again. So I move x to one side and the number to one side, another side. So 3x equal to 3. So therefore x is 1. And step 3, and as we got the x already, so what are we missing here? The y, right? So the step 3 is solve for the y. Okay, so we already got x is equal to 1, so we can use this one and transfer to both of this equation to calculate the y. So for example, I take the first equation, replace x equal to 1 to first equation. So I got y is equal to 2 multiplied with 1 and plus 1. So this one is equal to 3. So we already got the x and the y. So the answer is here is 1 and 3. Right? We can check the answer. This one is the same thing. It's the same answer as 1 and 3, right? Solving this using substitution. This one we got x isolated and the equation right here. We don't see like the both of the y are isolated like the first example, but we can also still use this method because we already see the x is isolated. So the first step is also replace x equal to 2y plus 1 to the second equation. So therefore I got 4 times 2y plus 1 plus y equal to 19. This will be 8y plus 4 plus y equal to 19. So in this one, we got 9y equal to 19 minus 4 is 15. So the y here is 15 over 9. So as we got the y, we need to put it in the first equation or second equation to calculate for x and replace y equal to 15 over 9 to the first equation. So with the first equation, x is equal to 2 multiple with and plus 1. So therefore, x here is 39 over 9. So the solution here is 39 over 9 and 15 over 9. Okay, so let's move on to our second solution, a second method to solve this system, which is elimination. Elimination here means we can eliminate one variable, like eliminate x or eliminate y from the equation so we can solve others. Right? Okay, so the first step is find least common multiple of x coefficient or y coefficient. Y coefficient is up to the question that if the x coefficients have the least common multiple is simpler or the y coefficient are simpler, so we can choose that. But in this question, as you know, the least common multiple of 2 and 5 is 10, and least common multiple of 3 and 7 is 21. So they both are not simple. So I just choose the coefficient of x, right? So the LCM of 2 and 5 is 10. It's 10. Okay. So the thing here is I need to make the coefficient of x from two equation that equal to 10, right? So at first I got this equation, which is 2x plus 3y equal to 13, right? So how can I make this one transfer to 10x? So I multiple with 5 for both sides. So 2x plus 3y multiple with 5, and this one is also 13 multiple with 5. So I got 10x plus 15y equal to 65. So I call this as 3, the new equation. So, and how about the second? The second I got, which is 5x plus 7y equal to 31. With how can I change this to like 10? So I need to multiple with 2 for both sides of this equation, right? So 5x plus 7y multiple with 2 equal to 31 multiple with 2. Therefore, I just got 10x plus 14y is equal to 62. I call this equation 4. Step 3 is elimination. Okay, so how can we eliminate that? We already got the 3, which is 10x plus 15y equal to 65, and 4 is 10x plus 14y equal to 62. So we already got 10x, same coefficient for two equations, so we can just minus up for both sides. 10x minus 10x is 0, and 15y minus 14y is y, and here's 3, so we got y equal to 3. And this last step is solve for x, solve for another variable that we unknown. So for x, in this example is for x, but for some example order it will be can be y or x. So as we got y is equal to 3, so we put that in the first equation, which is 2x plus 3y equal to 13. So what do we got here? 2x plus 9 equal to 13. So x is equal to 13 minus 9 divided by 2, which is 2, right? So the answer right here we got is 2, 2, and 3. For this example, is maybe look a little bit longer, but for some simpler equation, system of equations, this can be really simple. I just choose this one to solve the hardest one for you guys to understand how can we solve that and step by step. Okay, this is another example how to solve this using elimination. And in this one, in the first and the second equation, we can see the coefficient of x and y of the y are kind of similar. So we don't need to calculate for the least common multiple anymore. So in here we just come directly to the step 3, which is eliminate. So right now I write that again. 2y equal to 16 and 5x minus 2y equal to 4. Okay, with this situation we got plus and minus. So the simple idea here is that we need is we plus two sides of these equations together to make the y disappear, because plus 2x and plus 4 minus 2y is equal to 0. So in here we got 8x and plus 2y plus 4 with minus 2y is equal to 0. So you could put 0 here. So 20 or 20. So 8x is 20. So x here is 20 over 8, which is 5 over 2. Right? We already got x is equal to 5 over 2. So we can change to the first or second equation to calculate that. For example, I choose the first. So therefore I got 3 multiple with 5 over 2 plus 2y equal to 16. And this one I got 15 over 2 plus 2y equal to 16. So 2y are equal to 32 plus minus 15 over 2. So 2y here is 17 over 2, which is y is 17 over 4. So we got x here as this one and y here, so we can conclude that x and y is equal to 5 over 2 and 17 over 4 with using elimination. If we use the substitution in this part, it can be tough for us to solve that. Okay, and in last part is a conclusion, and in here I will list some of the situation that we use each of these methods to solve that. First of all is substitution. We can use that when there's a variable that isolated outside of the equation. Variable is isolated. So for example, like we got this one, as you see, the x is isolated on one side, or y equal to 2x plus 9. So y here also isolated. If we got some of this equation in the system, we definitely can use this substitution method. And how about elimination? Elimination, I would recommend use it when we got the standard form of the linear equation. Standard form, which is ax by equal to c and dx plus ey equal to f. And in this elimination can help us in better way. And another is complicated number coefficient, which is really big, which is have big LCM, right? With this one, using substitution can really difficult for us. And this is the end of the lesson today. Thank you for listening. Okay, this is the end of the lesson already. So if you need extra help, you can check in the description and reach out to me through Gmail or Facebook. I'm happy to help. Thank you.